Welcome to your sort of review on rational number operations. Just in case you were out of class, this is recorded for you. So let's get right into it. So if the signs on two numbers are the same, then all you're going to do is add them, and your answer is going to use the same sign. Okay, so for instance, over here, I have -2 plus -2. So I have negatives on both. So my answer is going to be negative, and then I just add 2 and 2. That's 4. Okay. Thinking of it on a number line, negatives are to the left, or negatives move to the left on the number line. Positives move you to the right on the number line. Okay, so you start at 0 and you say -2 and another -2, add them together and you get a -4. If the signs are different, then what you're going to do is you're going to subtract. And what you're going to wind up with is you're going to take the sign of the number with the greater absolute value. Let me show you guys an example of that situation. So this particular situation might be something like maybe 3 plus a -6. Okay, I start at 0 and I would go 1, 2, 3 because I go to the right if the number is positive. But then from here, I would have to go to the left 6 jumps because that's negative. 1, 2, 3, 4, 5, 6, and I would wind up right here. Okay, I wind up at -3. I wind up at -3 if I do my number line, but I also wind up at -3 if I just look at this as 3 and 6. 6 minus 3 is 3, and then I remember that the 6 really had a negative sign, and so the answer is going to have a negative sign as well, because the absolute value of -6 is greater than the absolute value of 3. Okay, so you can think of it that way. You can think of it on the number line. On the number line, when the signs are different, they're kind of working against each other. When the signs are the same, they're moving the same direction on the number line, so they kind of add together. All right, subtraction. Rewrite the problem to add the opposite. Then follow the rules for adding rational numbers. So basically make a change to where it's add the opposite, and then you come up here and follow those directions. Okay. All right. Rewrite the problem. This is really 6 plus a -10. Okay. So we did on the number line, we went 1, 2, 3, 4, 5, 6, wound up here, and then -10 takes us to here. Okay. If the signs are different, which remember we added the opposite to make it look like this, the signs are now different. This is a +6, this is a -10. I think subtract 10 minus 6 is 4, but I need to take the sign of the greater absolute value. Absolute value of -10 is greater than the absolute value of 6. So that sign wins. Okay, so if this is something that works for you just in your head, that's great. If it's easier for you to plot out a number line and do it that way, that's great also. Just remember, positives are going to move to the right on the number line, negatives will move you to the left on the number line. All right, multiplication and division. If there is an even number of signs, interesting. Okay, it says if there's an even number of signs, then the solution is positive. Even number of the same sign, then the solution is positive. Okay, let's clarify that. Because here I have a negative and a positive. Well, that's two signs, but they're not the same. So we needed to clean that up. If there's an even number of the same sign, then the solution is positive. So like -3 times -3, I have an even number of the same sign. So my answer will be positive. If I have one of each sign, or if I had an odd number, then the solution's negative. Okay, I don't love how that's explained, so let me see if I can clarify that. 2 of the same sign, your answer is positive, okay? So negative times negative equals positive. Positive times positive equals positive. Let me write, let's see. I'm running out of room. I'm going to turn this. I'm going to do this. 1 of each sign. Like if I have a negative times a positive, my answer will be negative. Okay? So hopefully that's helping. All right, I think it's probably best if we just get into this. So integer operations, we've got all sorts: add, subtract, multiply, and divide. Remember, I didn't really talk about dividing per se individually up here because dividing is really just the inverse of multiplication. So the rules about whether it's positive or negative are going to be the same as if you were multiplying. Okay, here, this is going to be 8 plus a -11. Okay. Your 8, you're going to go this way on the number line, and then your 11, you're going to wind up going this way. You're going to think subtract and take the sign of the greater absolute value. So the greater absolute value is the -11. So my answer is going to be a negative, and then I just take the difference. 11 minus 8 is 3. I have a -3 plus a -13. This time the signs are the same, okay? So it would be like -3 and then -13. So I'm just moving further to the left on the number line. So I'm going to think add and use the same sign. So 3 and 13 is 16, and they were both negative. I have one that's positive and one that is negative. If you have one of each, your answer will be negative. So 15 divided by 3 is 5, but I have one of each, so that is -5. All right. I have -4 plus a -6. So I'm just moving further and further into negative territory. So these guys actually have the same sign, so I think add and just put the same sign on it, -10. On this one, I have a +8 and a -2. So I have +8 going this way on the number line, and then a -2 going this way. That's basically the same as saying 8 minus 2, which is 6. It's going to be a +6 because the 8 is positive and it's a bigger absolute value. All right, 6 times -9. I have a positive number times a negative number. I have one of each being multiplied, positive times negative, so I know my number is going to be negative. 6 times 9 is 54. All right, now I have -27 divided by +9. Again, I have one of each sign. But Ms. Goff, it's division. Yes, but division is basically the inverse of multiplication, so the rules are the same. All right. So -27 divided by 9. My answer is going to be negative, and then I just think 27 divided by 9 is 3. I have +8 times +11. This is what we've been doing for a long, long, long time. And that is just going to be a +88. Why? Because remember, if we have two positive numbers being multiplied together, the answer is positive. If we have two negative numbers being multiplied together, the answer is also positive. Basically, if you have two of the same sign, your answer is positive when you're multiplying and dividing. Okay. This says 12 minus a -9. Go up here, rewrite the problem to add the opposite. Okay, so I'm rewriting the problem. 12 plus the opposite of -9 is +9. So lo and behold, this is really just 12 plus 9, and that is 19. Okay. All right, so now we have good old-fashioned just practice, more of the same. This is a multiplication. I have one negative and one positive. My answer, whatever it is going to be negative. Two fractions multiplied, but the two fractions are both positive, so my answer is going to be positive. Notice I'm not actually doing the math yet. I can do that in a minute. 12.7 times -12.7 times -3. I have two of the same sign. Even though they're both negative, I have two of the same sign. The answer is going to be positive. 2/3 times 3/2. I have +2/3 times +3/2. It's going to give me a positive answer. I have a negative divided by a positive. I have one of each, so my answer will be negative. 5/8 is positive, 3/4 is positive. Positive divided by positive, my answer is going to be positive. 100 divided by 2.5, positive 100 divided by positive 2.5, my answer will be a positive number. Positive 4/7 divided by positive 1/2, my answer will be positive. Now, why don't you go back? These are all either multiplication or division. Go back and do these on your own, and then check your answers after hitting pause. Okay? Let me give you a few more hints. Okay, so here you're going to set it up as a regular multiplication problem. Make sure to put one digit behind the decimal in your answer, and your answer is going to be negative. Here, when you're multiplying fractions, you just multiply the numerators for an answer, multiply the denominators for the denominator. Here, you're multiplying just like you normally do. Make sure to put one digit behind the decimal place in your answer. Here, you're just multiplying across, and simplifying. Here, 60.8 divided by 4 and get your answer. Dividing by a fraction, remember, you're going to keep the first fraction. You're going to change the sign and flip the second fraction. And now you just multiply across to get your answer. Okay? 100 divided by 2.5. I can make that 1,000 divided by 25. and then